Hey, Jacob Wallace here. Today I want to just give you a basic run through of carabiners. So we're just going to talk about all the basic stuff that has to do with carabiners. First off, we've got two main types of materials. We've got steel, like this carabiner here. This is a fusion captive eye black carabiner. And then we've got aluminum. Okay, and so the main difference you're going to see here is weight. So the carabiners that are aluminum obviously are considerably lighter, but generally speaking aren't as strong. So that's sort of the give-take you're going to have with material. Common stat you're going to see in our new catalog, it's going to have three main ones. It's going to have first a little carabiner with arrows sticking out of the ends. And what that one's referring to is the braking strength of the major axis. So it's basically like when you're pulling like this. This is the way that the carabiner is strongest, the way that it's meant to be used. Alright, and so for rope access, for high-rise window cleaning, for that type of stuff, Spratt recommends a carabiner that's at least 22 kilonewtons or 5,000 pound braking strength on the major axis. So pretty much all the carabiners we have are going to meet that requirement. But just make sure whenever you get a carabiner, you're looking for 22 kilonewtons on the major axis. The other ones you're going to see are carabiners sort of upright with the arrows coming out of these sides now. So now you're looking at minor axis. This is not a direction you usually want your carabiners to be pulled in, because they're not as strong as their major axis and they're not meant to be pulled on that way. So most of the carabiners we've listed what their minor axis strength is. And in fact, one of the standards that we'll talk about in a second has a stipulation about the minor axis. But generally speaking, there isn't a guideline for it. So there's also a third stat you're going to see, and it's sort of the same one as the first one with the arrows coming off the top and bottom, but it's with the gate open. So this is pretty much worst case scenario if you've got your carabiner loaded while it's open. So you've got it open for some reason and it's being pulled on. And so this is obviously much weaker than if the carabiner is actually closed, and you want to avoid that. But we've listed that stat for you. So basically now you know the materials and the strengths and the stats that we're talking about. So let's go ahead and talk about locking mechanism. First main locking mechanism we're going to see is the claw. And the way this one works is basically the gate of the carabiner and then the body sort of fit into each other sort of horizontally. And so that sort of adds strength, because once they're interwound, it's sort of like they're one piece of metal, so it makes it stronger on the major axis. Alright, and then the next type we're going to look at is key lock. Key lock is sort of like that, except instead of horizontally, it's vertically. So now we've got the body of the carabiner has this little shape here that fits into a corresponding key lock in the gate. So they fit together, and again, the way that latches together makes for more strength on the major axis. Alright, and then the last one we have to look at is, here we go. We've got pin and latch, or pin and notch rather. So this one has a little hook on the body, and inside here is a pin that it clasps onto. Alright, so those are your locking mechanisms. And then we've got two major types of carabiners based on the gate closure. And for those two we've got screwed, and so the way this one works is you unscrew the sleeve here in order to open the gate, and then you screw it back shut when you're done with it. Always make sure that your screw gate carabiners are closed before you use them. And then we have auto locking. Auto locking is where you open it and then you close it and it automatically closes, so you don't have to worry about accidentally leaving it open like a screw gate. So that's a nice feature. And then as far as auto locking goes, there's two main types. There's triple auto locking like this one. This is a Petzl AMD carabiner, and the way it works is you have to push the sleeve over and then twist, and then it opens. So that's your triple. You've got 1, 2, 3. Alright, some carabiners have double, so they skip the step where you push. This carabiner, the Fusion, all it has to do is twist, open. Alright, so 1, 2. that's your whole action there. And then the last item we're going to look at is the shape of your carabiner. Alright, so we've got 3 basic shapes. We'll demonstrate here with these Petzl carabiners. First, this is the Petzl OK carabiner, and it is an oval shape, and you can see pretty clearly why this is an oval shape. It's just shaped like an oval. And then this is the Petzl AMD, and this one is what we call a D shape. So it looks a little bit more like the uppercase letter D. And this carabiner is nice if you're working with a device like the Petzl ID or something that has like metal sleeves that are parallel. It helps you get over those parallel ones where you would have more trouble with the oval. And then lastly is the Pear Shape, sometimes called the offset D. It's basically like a bigger D where I could fit multiple items potentially, or bigger stuff, into this side because it's enlarged. So that's the basic shape. And then other than features of a carabiner, the last thing to mention is standards. The current standard that OSHA falls back on for lack of more applicable rope access standards is the ANSI Z359.1 2007 edition. And that will come up basically, it's a standard that relates to fall protection, but the rope access standards aren't very developed. So OSHA uses that sometimes, and basically what it is that the carabiner has to have a 3,600 pound gate strength. So now we're talking about the minor axis and some other stuff related to the gates. So only auto-locking carabiners you're going to see are going to have this, mostly steel. But all the ones in the catalog that are ANSI rated, that's going to be clearly marked in bold. And basically, you can use whatever carabiners you want, but if you're not using ANSI carabiners, you will have to justify that choice to OSHA if they show up on your job site. So just be prepared to do that, and depending on the OSHA person that you deal with, they may or may not let you off. So it's really a decision for the employer. Employer is always required to justify any safety decisions. So that's the basics of this standard. Thanks for watching.